Hi, I'm Candace from Topcon University. In this video, we are going to review the detailed pupil data provided by the MYAH in dynamic pupillometry mode. Let's get started. If you are starting from the home screen, select the Pupillometry tab labeled PUP from the exam preview list for the patient of interest. Then double-click the preview image for the right or left eye. Or navigate to the PUP or Pupillometry tab after entering the measurements page. If dynamic pupillometry was captured, rather than static measurements, the display defaults to dynamic. Select OD to view results for the right eye, or OS to view results for the left eye. You can review the dynamic pupil measurement video and see the pupil constricting and dilating as the light levels change from scotopic to photopic and back again. The pupil decentration and size on the left here relates to any selected point in the video, whereas the data above is the average decentration, along with the maximum and minimum pupil diameter during capture. The decentration is specified in XY coordinates in relation to the optical axis. In the display section, you can select what images will be superimposed over the video. You can select to show the ring center, highlight the pupil margin, overlay a grid, or a ruler. The Graphs tab provides additional pupil analysis. The Decentration tab shows the position of the pupil center throughout the dynamic pupillometry measurement. The center of the green rings is the optical axis, whereas the red dots are the location of the pupil center. Below pupil size, pupil decentration is specified in X and Y coordinates and also as polar coordinates with an amplitude and an angle, a value sometimes referred to as chord mu. Large pupil decentration values can result in visual disturbance in patients with multifocal contact lenses or premium intraocular lenses. In this example, the pupil is temporal to the optical axis by 0.14 millimeters and inferior to the optical axis by 0.08 millimeters. The Latency tab shows how quickly the pupil reacts to the change from scotopic to photopic lighting conditions and back again. The red zone indicates scotopic conditions, the green zone indicates the pupil contraction, and the blue zone is the dilation. A slow pupil latency can be associated with visual symptoms, particularly when driving in variable lighting conditions. The Statistics tab provides information on the variability of the pupil diameter under the 3 different lighting conditions. And that's an overview of the pupillometry data provided by the MYAH. Thanks for watching. For more information, please visit Topcon University.